Number 9, which of the following sequences is a geometric progression? We have two types of progressions. We have arithmetic and geometric. An arithmetic progression is where we would just start with a number like 4, and let's say we're adding something each time. So let's say I'm going to add 3. So 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16, and so on. So every time we move, our rule is add 3. When we have a geometric progression, we'd start with a number, for instance, 4, and then we would multiply by a particular number. So let's say I'm going to do 4 times 2. So 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And it would just continue. So this is an arithmetic. This is a geometric, where every time we go, we multiply by 2. Here, we're only adding each time. So we're going to take a look over here and see which of these we're actually multiplying on. So let's see what we multiply by on this one. Here, 3 times 5 is 15. 2 times 3 is 6. So we should always be able to do this times 5 and 3. So if we do 15 times 5, so if we just go over here, 15 times 5, 5 times 5 is 25, carry our 2, 5, 6, 7, that's 75, so that works out. Then this would have to be always times 3. 6 times 3 is 18. So yes, this is a geometric progression. So now I'm going to look here. I can see here I would multiply by 2, but when I try multiplying by 2 there, it won't work. So I automatically know I don't even have to go to the bottom here, but I don't even have to do anything, because I can see this will not always work, will not always be the same number. So for instance, for here, we can see the 7 times the 3 would be that, but it wouldn't work for this. And then here, we're going to take a look at what we're doing. 4 times 3 and 12 times 3. So that is the geometric progression. To do this, we can always take our second number over the first number. So this, 12 divided by 4 equals 3. And then if I do 36 divided by 12, it's going to equal 3. And the same will work for these.